Hello everyone, today I will showing how to draw a response spectrum. So let's start. I will try to draw this response spectrum. At first we have taken the soil factor, which is giving the BNBC and ASCE-7. Here is the BNBC books and here is the ASCE-7-05. So I am following BNBC and ASCE-7. So here is the soil site factor. So depends on the various type of soil, which is SA, SB, SC, SD, and SE. Here is the soil factor, which is 1 for SA, SB for 1.2, SC for 1.15, and SD for 1.35, and SE for 1.4. And there is the time period for different as TB, TC, TD, and difference and many. So I'm just taking this value in Excel here. At first S 0.1, 0.1, and 0.2, 0.5, 0.5, and 1.4 and 1.4, and SB 0.5, 0.5, 0.20, 0.20, 0.5, 0.5, 0.20, 0.20, 1.5. In the same way, 0.40, 0.50, 0.60, 0.80, and 0.50. 0.40, 0.50, 0.60, 0.80, 0.50. In this way, I am taking all these value. Okay. Second, I am taking the damping correlation factor phi. Damping correlation factor phi here. The damping correlation factor as a function of damping with a reference value of eta equal to 1 for 5% viscous damping. It is given by the following expression. So this equation I have used, where zeta is a viscous damping for the damping ratio of the structure express the percentage of the critical damping, for value of n cannot be smaller than 0.55. Okay, so the value must be greater than 0.55, but we will calculate 1, the viscous damping. So putting this value and taking the zeta equal to 1, and put this all the value 10, 5 plus 5, so equal to 1. So equal to 1. Okay. In the response reduction factor, we have found response reduction factor is depends of the various seismic force systems. So response reduction factor, it is also response reduction factor, also the deflection amplification factor, and so on. So at first the bearing wall system, so there is no, and another was building frame system with bracing knot. The moment resistance frame system, no shear wall, we will use this. So our seismic force resisting system or seismic reinforced concrete moment frame. So that's why our response reduction factor is 8. Sorry, response reduction factor is 8. So we are taking the 8. In this way we have taken the I, but it is okay. I'm just showing how why I have taken here. As the importance of factor of building is 3 and found 1.25. I have taken 1.25, and Z value is a zone coefficient. Our zone coefficient is mimicking, so that's why we have taken 0.30, and G-rock is equal to 2.3. Now we will go for here is a G-rock. It is shown that 2/3 into Zi by R, 2/3 in Zi by R, and found 0.330. We have seen the another normalized acceleration response CS equal to 4 no, four what I will say the four formula. One is here, uh, 1 2 3 4. So first is for when 1 second 0 to TB, and another one CS TB to TC. So first is this formula used for 0 to TB. 0 to TB means here we can see 0 to TB. TB is 0.5. So 0 when the use is 0, and we will go to the 0.5. So at first I am seeing here is a 0 and TB will be 0.5. So the first formula will be CS. CS will be used 0 to 0.5. Okay. So I am using this first formula I have applied here. This is the first formula. S into 1. S is cell number 512, whereas yes, cell number F is 12. So yes into 1 into 1. So here is the into 1 plus T divided by TC. T means here C33, and divided by TB. Divided by TB is cell number 12. Here is a TBG 12 is a TB into 2.5 into N eta. 2.5 into eta. Eta is a damping coefficient factor, which is cell number E12 E20. Here is the E20 N minus 1 N minus 1, and putting enter. So I'm just working this as a fast, and dragging this value up to 0.15. Why? Because 0 to TB. So TB value we can see TB value is 0.15. That's why we will use this formula 0.15. Okay. And second formula, we have shown the second formula is here CS 2.5 S into N, which will be used TB to TC. So TB, we know the value of TB 0.15, and TC TB equal to 0.15 and TC equal to 0.40. So the second formula will be used 0.15 to 0.40, and this portion will be our second formula. Okay, so second formula 2 into S into N. 2 into S. S is found cell number F12. Here is the F12 into eta. Eta will to found cell number E20. E20 here is the E20. So putting enter and found 2.40, and dragging this formula up to 0.40, and found this, and this is the second formula we have used. And in the same way we will use third formula. Here is the third formula, CS third formula 2.5 into S into eta TC divided by T, and this value will be TC to T. TC means 0.40 and TD equal to 2. So we are saying TC equal to 0.40 and TD to 2. So the formula will be used to 0.40 to 2. We have seen here the time period is 0.40, and it will be used to up to 0.2. I want to say that the this time period I have taken the interval of 0, 0.50 and 0.10, 0.25. This is our assumption. We are taking the 0.50 interval. You can use in your own in a small little portion, but I have taken 0.50 interval. Okay, so that was our third formula. Third formula is 2 into S into eta. 2 into S is found cell number F12. F12 is S, and E20 is a damping coefficient factor E20. and S12 equal to here TC, the value is S12, and divided by C12 C20 divided by T is here the 20, and putting enter, and this value will take the TD means point up to 2 point. So this is using. And the last one we have shown the last one is CS is here, and the value will be TD to 4 second. So I have already putting this up to 4 second here. So the fourth the fourth formula is 2.5. So 2.5 into S, 2.5 into S. So S is the S is the cell number F12 as a S, F12, and E20 S into N, which is a damping coefficient. E20 here is a E20 E, and 20 as a damping coefficient, and S and TCTD means H12 and I12. So TCTD H12 and I12, so TCTD, and we can see divided by T square. So T square means here the C74 square. So putting enter and dragging this formula up to 4 second. So up to 4 second. Okay. So we have found this. So this is our assay. So if we want to draw the response spectrum of SA, this A, so we can go to the insert menu and go the insert scattered, and here. So I'm again go insert scattered here. So putting this select data and add the serial name is SA, and X value we are putting the time period 4 second up to, and CS we are getting the CS this value up to 4 second. Okay, we have found this value. This is the response spectrum of SA. We can see here the SA response spectrum of SA. So we can say here the time period T is a second, and here is a CS. Okay, x-axis is the time period up to 4 second, and y-axis is equal to CS. So you can reduce the value up to 4 second. Okay, here is the value of S. So it will be response spectrum analysis. Okay, in the same way I have putting the all the value SB. SB we will use this for formula 1 2 3 4 again. Again I am formatting this value and just dragging and found CS. In the same way in the same way second formula we will use, and the third formula we have used. This is the third formula. This is the third formula we have used here. Sorry, the third formula will be 2.2, and this is the fourth formula. So I have used the fourth formula. In the same way in the same way I have used the SC. The first formula is here. The first formula is the first formula. So first formula is applied here up to, and the second formula is applied. This is the second formula. and this is the third formula I have applied, and this is the fourth formula. Third formula is here, and this is the fourth formula we have applied here. Okay, so SC is done, SD is here. At first I am doing here. The first formula here is done, the second formula is here, done, and the third formula is here. I am formatting these below, and the fourth formula is done. Okay, so SD and SE in the same way. First formula is done, and second formula of CS is done, third formula of CS is done, and fourth formula of CS is done. So all the CS is plotting found, and now we will plot the in the same way SB. So SB is here, and X value is a time period, and Y value is a CS. So here is the CS Y value up to 4 seconds. So this is our SB. So looks, this is our SB. So we have calculating plotting to SA and SB in the same way. We will plotting SC. So this is SC, and X value is time period up to 4 seconds, and Y value is a SC. Okay, here is SC. So SC SC is drawn. So we can see the SC is the lower highest of SB. You can, if you see the response spectrum curve on here is a SC, but SB is here. Here is a SB. SB is longer than SC, but SC is smaller than SC. So I have drawn 1, 2, 3 curve. In the same way, we will take the SD. SD is here. At first I have tried SD in lonely or selfly, and then I'm trying to make a video for the help of people, and the value is taken up to 4 seconds. So SD is also done. Here is a SD also done. In the way of SE. So SE, the x-axis will be time period, and the y-axis will be SCS. CS is normal oscillation response spectrum. So normal oscillation spectrum. So finally I have drawn the response spectrum is here. If we go to the this picture, so we can see all the value we have found. So the value this picture and this picture is same. We have seen the CS here, here, and time period is x-axis, time period is x-axis. So this is our response spectrum of CS versus time period. If you want to draw the time period versus SA, so we need to SA means the PGA rock. So PGA rock CS equal to SA divided by G. G means PGA rock, or we have drawn here. So the SA will be so if you want to SA, then what we need to do? So SA into CS into PGA rock. So if we we know the CS value, so we know the CS value, just we need to the PGA rock. So if we can go the here at first we have gone to the PGA rock. Here is a 2/3 into zi by r. So if we found this value and multiply with this, then we will go to we found the SA. So we can already calculated the PGA rock, which is 2/3 zi by r. Here is the value. So if we multiply CS into G, CS into this value, then we will get the SA value. So I have already putting this formula here. I'm just clicking and found here for fourth, and this is the for fifth. And in the same way you can use SA, the second for SA. So here you can see the first cell and this cell PGA rock, and multiply and found this value. There is nothing what I will say, nothing new. So CS into here, we can found all the value are same. I'm just deleting this value, it's irritating because we don't need this value. So if you want to SA, so I know the SA value will be CS into 0. So here is a CS into K33 into 0 is here. So putting enter and drag all the portion and found the value. In the same way in SE equal to CS into PGA rock, and putting enter and clicking on, that's we will found. So response spectrum we have drawn here. We can see the CS versus time period. If you want to draw the SA versus time period, we can also draw. So we can go to insert and scattered menu and enter and insert and add. At first we want to draw this. Okay, so I want to draw SA versus time period. Click enter and putting the series name SA. X value is time period up to 4 seconds, and Y will be SA. SA means the acceleration, spectral acceleration. So SA. So this is the value. This is our response spectrum of SA versus. I'm just giving region and something. The value will be x-axis is time period, which is second, and y-axis will be SA. The unit will be meter per second square. Because this is the spectral acceleration, so this is the spectral acceleration or meter per second square. In this way we will add the SB axis is here, and y axis will go as a spectral acceleration SB. Here is a SB, S and SB. In the same way we will input the SC, the x value is time period, and y value is as spectral acceleration. Okay. Okay, this is the ASCE. In the same way, we will input the SD. SD is here, and x value is a time period up to 4 seconds, and y value will be as which is a spectral acceleration. Okay, we have done the SD. Here is a SD. And the last one we will graph the value of SE, and the x value will be time period in the same way, and y value will be spectral acceleration. Okay. All the graph we have shown. Here is the spectral acceleration divided by time period. At first I have drawn the CS versus time period. I am taking to response spectrum here. So at first we have taken the CS versus time period. We have shown here the CS versus time period. This is our response spectrum. At first we have drawn here, and then you can also use the acceleration versus time period. You can also velocity versus time period. You can also displacement versus time period. I will make another video for velocity versus time period and displacement versus time period, how to draw the response spectrum against this plot. So thank you. If you have any question, then let me know. I will thanks again. Thank you everyone.